Hello, this is Dr. Hassan Abdullah with the course Introduction to Natural Language Processing. And we are here with lecture number 2, which is text processing. And here is the supplemental website www.easymcq.com/goget. So, this course consists of multiple topics and it's a very comprehensive course which covers a lot. The topic which we are covering in this lecture, in this video lecture, is text pre-processing. And this course is supported by a supplemental website, which is basically a learning management system. The address is in front of you, and it consists of very powerful 8 features that are divided into 6 lectures, 6 video lectures over here. And I would suggest you to view those lectures so that you can effectively succeed and proceed in this course because this LMS is a very powerful tool. So now we move on to the LMS easymcq.com /GoGet. As you can see, there are quite a few cutting edge courses, including the basic and the fundamental computer science course of data structures and algorithms. Then there's machine learning, there is artificial intelligence, and there's more. So I would welcome you to try and explore those courses. And now we move to the course of our interest, which is natural language processing. And this consists of quite a few 15 topics, and we move on to the topic of our interest, which is text processing. And as you know, that the course is structured in the form of questions and answers. So the first question is, what is text processing in NLP? Text processing could be in other subjects and courses also, but how it is related in natural language processing? So it consists of tokenization. Tokenization means that breaking your paragraphs, your sentences into pieces which are more manageable, and lowercasing, converting the case from uppercase to lowercase. I'll give you examples about it and discuss this. And then the stop word removal, like and, is, the, and so on. Punctuation removal, single quote, double quote, colon, whatever. And of course, in sentiment analysis, they matter a lot. Then stemming in lemmatization, uh, going towards the base word, running versus run, and better versus good. So that good replacing better by good is lemmatization. Text normalization, bringing it to a standard form, handling numbers and special characters. In certain cases, removing them, but in certain cases, like hashtags or Twitter tweets, keeping them. And n-grams generation, the length of one or two, and so on. And of course, the vectorization is a model for representing the text. So I've covered almost all of it. So basically, stemming and lemmatization, running becomes run, right? And of course, there are certain benefits of this approach, which I will also discuss in the subsequent Q&A. Handling numbers and special characters, removing or replacing with the placeholders, but not every time. N-grams, contiguous sequence of n words or characters. For example, bigrams and trigrams. Bigrams and trigrams help capture the word combination and the context. This helps in understanding of the language. I'll give more examples and discuss this. And of course, vectorization after pre-processing the text into numerical format, a bag of word model, which we will discuss in the subsequent sections and topics. And then, of course, term frequency in inverse document frequency and Word2Vec and so on. So these all constitutes text pre-processing. So why is text pre-processing important? That's the main question. Reduces the noise, removal of irrelevant special characters, extra spaces, spelling mistakes, uppers and lower cases, and so on, improves model efficiency. When it is converted into more uniform and structured format, the pre-processing of the model ensures its accuracy. I'll discuss more about it. Enhances accuracy, which I already discussed. Facilitates better feature extraction. Features are, you can say, some of the key components in text which are important and which help a lot in the applications in the downstream. So that becomes more efficient and accurate. So what is actually tokenization? Tokenization can be a it can be consisting of a word. It can be consisting of a sentence. So I have a paragraph. So a token could be single words. It could be a sentence also. It could be a character. So, for example, in hello, every letter can be a token. And then there's the subword tokenization. Let me give you some examples. So, for example, natural language processing is fun. So, the word tokenization consists of every word as a token. And of course, is there, and the exclamation sign is also there, which may get removed during the stop word removal. And sentence tokenization, I love NLP, it's fascinating. So, it's two sentences. And then is character tokenization, which I've already mentioned. So, subword tokenization, for example, meaningful subword units often used in modern NLP models like BERT and GPT. We will also discuss them. This is just the beginning of this topic and this course. And if you would like to know more about them, so these are the references. You can study them also. So, what is the importance? So, this question was basically what is tokenization? Now we look at what is the importance of tokenization. Text has segmentation. It breaks them into manageable chunks. Like say for example, if we buy a chicken and we basically eat the chicken bite by bite. So one approach is to first cut down the chicken, or maybe we get it a chopped chicken. So we are able to eat it bite by bite. So it helps. Okay, it is manageable. And then is foundation for further processing. In text classification, part of speech tagging, which we will discuss, name entity recognition, and so on. This tokenization helps a lot because that makes the text manageable. And then is the normalization. Normalization, for example, going to the root words, recognizing that running and run stem from the same root word. So basically, it also reduces the complexity of the problem because the number of combinations are also reduced as we discussed in the basics lecture. Improves model accuracy, focuses on understanding the meaning of individual words or phrases instead of targeting the entire paragraph or the entire document. Handling the ambiguity, for example, when we break them into tokens, then, for example, if you're looking at the bank, so the bank could be referring to the bank of a river, or it could be referring to the financial institution, or it could be a bank trusting somebody. So there can be many meanings. So when we do the tokenization, then we can focus on the and the application can be actually focus on the word itself. Better representation for language models. For example, models like Word2Vector and GloVe models, which we will discuss, so it becomes manageable and facilitates translation and understanding. Translation and understanding because they are properly parsed and mapped between languages. So that helps a lot when we translate from say English to Urdu, or from say from I don't know, from Russian to German, and what, and of course other options are also there. So what is the role of lower casing in pre-processing? Reduces the redundancy. So I can have Apple with a capital A and with without a capital A. So they have different. Lowercasing ensures that both are treated in the same as the same token. Now somebody would argue that they are different. Well, as a token they are same, but they have a different meaning in the context, which will be covered in different models. Improves the efficiency. So fewer unique tokens. So the complexity of the problem which we discussed, that decreases because there are less, the number of tokens is reduced, that's why. And of course simplifies text representation. So in different documents they could be capitalized or uncapitalized. So when we have simplified representation, then all of them are in lowercase. Consistency across documents, that I've already mentioned, reduces overfitting. So the application does not memorizes a certain case sensitive or certain cases of the words. So so lowercase words are get all kind of equivalency instead of some uppercase, some lowercase. Helps with language variations where capitalizations are inconsistent, such as social media posts. So maybe we would like to keep them. So that is the case for when lowercasing might not be ideal. For example, in German language, for example, when the case is very important, and of course when we are looking at certain types of social media posts. So now we move on to the next set of Q&A. So now the next question is, what is stop word removal and how it should be applied? So the stop word removal consists of the stop words to be removed, and this is a list, a partial list of the stop words, and they of course prepositions, pronouns are also included in it. So when should the stop word removal be applied? Uh, do not add much value in the task like text classification. Okay, so for example, if I want to classify this is positive or negative, or in sentiment analysis, maybe that is not very useful of having and on and in and so on. Feature extraction, removing stop words can reduce the size of the feature space, like bag of words and TF and IDF, because they are not adding any value, because they are occurring so much frequently that they it means that they don't have any value to it. When they do not carry task relevant information, of course if they have that value, that information, then they are included. And of course when we consider the n-gram size, and when should it not be applied, for example like machine translation, because these stop words add a lot of meaning to the sentence and to the group of words, requiring the word order. The order of words is important, grammar is very important, and of course in summary it is basically task based. What are stemming and lemmatization and how do they differ? Okay, so lemmatization and stemming, they are both basically going towards the stem. Okay, but they do it very different way. For example, if I say running versus run, so the run is the stem. Okay, and when we say good, better, and best, right? So best and better, okay, their lemma is good, that adds uniformity. But of course, if we do a stemming of better, it becomes bet, which is kind of meaningless in the context. And so this is how they differ. So how do we handle punctuation and special characters in text processing? We can either remove them, we can replace them. For example, we replace ampersand by and we preserve them, we keep them, and we do a normalization. For example, instead of writing don't with the colon, replacing it with don't, as I've shown here. So that they basically kind of standardizes. So what are n-grams and why they are important for text pre-processing? So n-grams basically is a group of words, okay, which we will consider as a unit. So you can have unigrams, a single word. We can have bigrams. For example, don't like is a bigram. And for example, trigrams, don't like sugar. So that's a trigram. So depending upon the documents and the text we are working with, either of them would be a good choice. So what is the importance of text pre-processing? They capture the context. Because if we have unigram, don't like, and we then we have don't and like, and we have sugar and say honey also. For example, the sentence is I don't like sugar but like honey. So if we do a unigram, we lose the meaning. So maybe the trigram or a bigram is a better choice. So they captures the context, improving the model. So how does it improve the model? For example, where the order of words significantly impact the model's understanding. Order of words is very important. Feature extraction. Various machines allow model to understand word associations because the word occur in a certain sequence for a certain in a certain context. So there's we need to preserve that word association and handling the ambiguities to help disambiguate meaning. Because if we have a bigram, maybe it doesn't make more sense as compared to having a trigram. And how do we handle the spelling corrections and typos in pre-processing? We can use a spell checker. V means the algorithm or the tool. Contextual spelling correction. It means that the spelling is assigned based upon the surrounding words. Phonetic meaning matching the spelling is assigned based upon how the words sound, how the words rather than their exact spelling. And manual or rule based, this is not a very attractive approach because the things are changing rapidly, and of course use of external data sets like Wikipedia. So now we move on to the next set of questions and answers.